Okay, so in this example, we're going to solve a couple of log problems where the rules, that those three common rules, which are right here, those three rules, they sometimes confuse students, like when are you allowed to use them, when not. The key, though, is always if x and y are both positive, if the two things you're trying to combine are both positive, then you can use the rules. So down here, I've got ln of something times something else is 3 ln of 2. Okay, so let's look at that. Ln x minus 3 x plus 4 equals 3 ln of 2. Okay, let me write ln the same way. Okay. So good thing to do out of habit is let's look at the domain. So right here, the thing we know about this is that anything I plug into a log has to be a positive value. So I know that this has to be positive. So since this is a quadratic, we would end up needing to look at a sign chart for it. So the zeros on this sign chart, x minus 3, x plus 4 is what we're testing. And we're plugging in x's. Okay, the zeros would be at -4 and at +3. And if you test in, or if you plug in test points, you get positive, negative, positive. So the domain is going to be -infinity up to -4 union 3 up to infinity. Okay, so there's one part. And if you think about this, it's something times something else. So they could either both be positive or they could both be negative. And if they were negative, then you're not allowed to turn it into the version that's in part B, because then you're not following the rule where it says it only works if they're both positive. So let's figure out a way to solve this. Now, if you look over on this side, 3 ln of 2, I can turn that into ln of 2 cubed, where it's sort of the reverse of the rule we've used a lot, where I bring the power up. And I'm allowed to do that because I know 2 is positive. So this is going to be ln of 8. So now what you've got is ln of this thing equals ln of 8. So that really means that the insides have to be the same. So x minus 3 times x plus 4 has to equal 8. So at this point, it's just a quadratic that you have to solve. So if you multiply this out, you get x squared plus x minus 12 equals 8. And then I'll subtract the 8. So I get minus 20 equals 0. This is factorable by hand. So you get x plus 5 and x minus 4 equals 0. And then if you solve this, you get x equals -5 or x equals 4. And if you look at whether or not that works in your domain, they both work. So they're both valid answers. Okay. In part B, we have a different version of this problem. So in part B, we've got ln of x minus 3 plus ln of x plus 4 equals 3 ln of 2, which we already said 3 ln of 2 is ln of 8, so I'll just write that here. Okay, so if we look at the domain for this one, we know that this guy has to be greater than 0, so x has to be greater than 3. And we know that this guy has to be greater than 0, so x has to be greater than -4. And they both have to be true, so really you can sum all that up with just x has to be greater than 3. Okay, so that's my domain. Let me get rid of this. Okay, domain x has to be greater than 3. Okay, well, I do know that, I'll highlight these. This one's positive, and this one's positive, because otherwise I wouldn't be allowed to plug them into ln. And since they're both positives, I'm allowed to combine them using that rule from above. So this turns into, oh, that's a thick marker. This turns into ln of x minus 3 times x plus 4 equals ln of 8. And then it's exactly the same as the problem above. Ln of this problem equals that. And so we can use all this same work right here. So I'm just going to copy all this. Copy. Paste. Right there. And the only thing you have to do now is we got 4, which is in my domain. And we got -5, which is not in my domain. So I'm going to cross off the -5. Only 4 works in this example. Okay. So hopefully that makes sense. Sort of gives you an idea of what pitfalls to try to avoid when using these 3 rules right here. And always remember this idea. X and Y both positive, then you're allowed to apply those rules. Okay, hope that helps.